So here we'll look at the two extremes. One is where the third side is the longest, and so to make it the longest, so for example, if let's say this is what the quadrilateral looks like, 4 centimeter. This is one possible scenario, and I need to maximize this. So that means that I can keep these as flat as possible. So let's say this is 1, 2, and then this is 4. Then we have this, and there's a kink here so that you know it's a quadrilateral. In that extreme, you can see that it would be as long as possible, and if you made it almost flat, of course, if it's a flat, it's no longer a quadrilateral. So we know that the third side, let me just call that x, has to be less than 1 plus 2 plus 4. You can imagine just kind of lifting it up a tiny bit here, and then connecting. So it would be kind of the sliver of a quadrilateral. But in that extreme, we know that the fourth side has to be less than 7. And we'll use the same logic to figure out what's the shortest I could make. So I need to bring these ends as close as possible. So what I'll do is I'll flatten these two because they're 1 and 2. This is 4. That's the longest. So you can think in terms of 1, 2, and then maybe make the 4 along this line. So then the fourth one will be something like that. So this is 4 centimeters. As you can see, the closer I bring this, make it flatter, this will be shorter. And you can see in the limit that if this is flat, that's flat, 1 centimeter, 2 centimeters, and then this has to be greater than 1 centimeter, the difference between these two. So I also know x has to be greater than 1. I hope you can kind of recognize this, that if you just kind of lift these up tiny bit, it will be a thin sliver of a quadrilateral. So the inequality that we're interested in is that. And we're told that that fourth length is constrained to be an integer. So the possible values are 2, 3, 4, 5, and 6. They're asking how many do we have. We have 5 possibilities, so the answer is A. I also want to mention that this is kind of the same logic you can use for triangle inequality. And that's also an important concept you need to know, where the third side is greater than the difference in the length of the other two sides. I'm using absolute values so you can subtract either one, and then less than the sum. So make sure you understand where that comes from. Very similar concept here. In fact, that's exactly, I knew this beforehand, and I also knew how to visualize the same process for triangles, and I hadn't thought about the quadrilateral, but that's kind of the same idea. So make sure you understand this. That's the relevant part. So to summarize, the answer is A.